All right, we've been drawing a lot of Lewis structures, but one thing that we need to talk about is the fact that the Lewis structure does not give the shape of the molecule. The shape of the molecule is the shape that the molecule takes up in three-dimensional space. And when we draw a Lewis structure, we're drawing something flat on the paper. And I have encouraged you not only to draw it flat on the paper, but always to draw it in the up, down, left, right position, because that makes counting to 8 easier. Sometimes with expanded octets, you might have to stick things off the corners, but in general, what we're showing with the Lewis structure is we're showing who's attached to whom, who's bonded to whom, whether they're single bonds, double bonds, triple bonds, and where the lone pairs are. This does not tell you what the shape of the molecule is. So what we want to talk about here is we want to talk about, well, what is the shape of a molecule? What does it look like when we take it into the laboratory and we study it? We can see where the nuclei are. We can see the angles that the bonds go off next to each other. What kind of generalities can we say about what the shape of the molecule looks like? Of course, if there are only 2 atoms in a molecule, if we only have 2 atoms attached to each other, however they're attached, either with a single bond, double bond, triple bond, doesn't matter how many lone pairs there are on any of the outside atoms, if you only have 2 atoms attached to each other, you're looking at something that's described as being linear. But if there's more than 2 atoms, then how are those atoms going to arrange themselves in space? Essentially, after studying many different types of molecules and seeing what they look like in three-dimensional space, we have a theory as to why molecules form the shapes they do. And that theory is called the VSEPR theory. VSEPR stands for valence shell electron pair repulsion. When we say this out loud, when we talk about this theory, we often refer to it as the VSEPR theory. I guess it should be VSEPR, but we say VSEPR theory. And so essentially what this theory says is that the valence shell electrons, which are the ones that show up in the Lewis structure, those are the ones that we count, those are the ones that we draw, those include everything that's bonding as well as the lone pairs, but the valence shell electron pairs repulse each other. And that is absolutely true. The only thing that I might do to improve on the name of this theory is instead of calling it pairs, I would call it groups. Valence shell electron groups have a repulsion for each other. The reason why I would change it to groups is because sometimes we see electrons that aren't just a pair of electrons. Sometimes there might be more than just a pair of electrons that would count as a group for this description of what we see happening. The valence shell electron group repulsion theory essentially says that the groups of electrons around the central atom want to be as far away from each other as possible. That is what dictates what shape they will take around the center. And we will always focus on the central atom in a molecule when we describe its shape. If we mean anything other than the central atom for the shape, we'll have to indicate it in the question specifically. Otherwise, if somebody says, what's the shape of this? Your job is to focus on the center and talk about the shape around that center. And what we find in terms of the electron groups around a center is if there are 2 electron groups, those groups will want to get as far away from each other as possible because of the repulsion they have for each other. And geometrically speaking, 2 groups get as far away from each other as possible from the center by going straight out on either side. The geometry of this is that this is about 180 degrees. Not about 180 degrees, it's 180 degrees. Remember that a circle is 360, and so this would be 180 degrees from each other. And this is how 2 groups will get as far away from each other as possible because of their repulsion. 3 groups will get as far away from each other as possible around a center atom, around a central point, by going in roughly this geometry. That's not too bad. Here we have 3 groups spread out as far away from each other as possible in the shape of an equilateral triangle. That means that our groups are 120 degrees apart Each two groups are 120 degrees. And even in three-dimensional space, this is how they get as far away from each other as possible. If I would think of this group pointing up in my picture, if I would think of it coming out of the paper towards you, like going in three-dimensional space towards you, it would actually get closer to the bottom two groups. So it's not going to do that. Because of the repulsion, these three groups want to get as far away from each other as possible, and this is exactly how they do so. Four groups is a little trickier to draw, but if four groups want to get as far away from each other as possible, around a center, geometrically speaking, it would look something like this. Now, I have tried to draw it in three-dimensional space. My drawing is not very good. We'll go look at a picture in a second. But essentially, one group goes up, another group goes down and at a slight angle down. A third group comes forward out of the paper towards you, slightly down, and then the fourth group goes behind the paper, again slightly down. The approximate angle between the groups here is approximately 109. It's very close to 109.5, and then these two would be 109.5 away from each other. These two are 109, and these two, one's coming forward and other one's going behind, these would also be about 109 degrees from each other. If we look at what this shape looks like in a better rendered three-dimensional shape, we would see something like this. All right, this one shows it maybe a little better over here on the left. The green is the center, the red is going up, this red is down and to the left, this one is coming forward, and that one is going behind. We do see some names on these too. Let me get back to the other page and we'll talk about the names of these. All right, the names of these images that we've talked about here are very specific in terms of what we call them as chemists. We call two groups around the center linear. Three groups around the center, we'll call this a trigonal planar. It is a triangular shape, and so trigonal or trigonal. Planar, it is flat in the plane of the paper, so planar. And then this shape is called a tetrahedral. A tetrahedral or a tetrahedron, four groups around the center. We've seen this tetra prefix before. This is how we describe this shape.